Picture this. You're flying toward Jupiter in a spaceship. From far away, it looks calm. Soft stripes of white and orange, a big red circle, a storm wider than Earth. Pretty, right? Peaceful, even. But then you get closer. Your radiation alarm starts screaming. Your screens flicker. Your tools break one by one. Then it hits you. This is no gentle planet. Jupiter is a bully hiding in plain sight. And by the end of this video, you'll understand why even our best robots barely survive a visit. Some never come back at all. First, let's talk size. Jupiter isn't just big, it's scary big. You could fit 1,300 Earths inside it. That's like putting 1,300 marbles into one giant bowling ball. But here's the number that really hurts. Jupiter weighs 2.5 times more than every other planet, moon, and asteroid in the solar system combined. Every rock, every world. Jupiter outweighs all of them twice over. But here's the creepy part. Jupiter almost became a star. If it had been just 80 times heavier when it formed, its core would have lit up with nuclear fire. We would have had 2 suns in our sky, a binary star system. Earth might never have formed at all. Instead, we got something possibly worse. A gas giant with no solid ground, insane pressure, and a hunger that changed the entire solar system.
Now look at its sky. What you're seeing isn't weather, it's a nightmare. The Great Red Spot alone has been spinning for at least 400 years, maybe much longer. That single storm is wider than Earth. You could drop our entire planet into it and still have room left over. Wind speeds at its edge hit 400 kilometers per hour, and on Jupiter, that's considered calm. Deeper in the atmosphere, jet streams tear across the planet at over 600 kilometers per hour. These aren't breezes. These are walls of gas moving faster than the speed of sound on Earth. But the storms aren't even the worst part. The deeper you go, the worse it gets. Jupiter has no surface. There's no ground to land on, no solid place to stand. The atmosphere just gets thicker and thicker. Pressure rises with every kilometer you descend. At a certain depth, the pressure becomes so extreme that hydrogen, the lightest gas in the universe, the stuff that floats away from Earth, gets squeezed into liquid metal. Liquid metallic hydrogen. It sounds like science fiction, but it's real. Scientists have made it in labs for split seconds. On Jupiter, it exists for millions of years. And this liquid metal creates something truly terrifying.
Jupiter's magnetic field.
Earth has a magnetic field too. It protects us from solar radiation, it deflects dangerous particles, it makes life possible. Jupiter's magnetic field? It's roughly 20,000 times stronger than Earth's. If you could see it with your eyes, it would appear larger than the full moon in our night sky, even though it's millions of kilometers away. That magnetic field stretches millions of kilometers into space. It reaches all the way to Saturn's orbit. It's the largest single structure in the entire solar system, and it's completely invisible. But here's the trap. This magnetic field doesn't protect, it destroys. Jupiter traps charged particles from the solar wind, the same particles that give us beautiful auroras on Earth. Then it accelerates them to nearly the speed of light. These particles form radiation belts so intense that they would kill an unprotected human in minutes, not hours, minutes. When NASA's Juno spacecraft entered Jupiter's orbit, it had to carry a titanium radiation vault just to protect its electronics. That vault weighs 200 kilograms, about as much as a large motorcycle. And even with that protection, Juno can only make close passes for a few hours at a time. After that, the radiation threatens to fry its systems completely. The Galileo probe plunged into Jupiter's atmosphere in 2003. Before it was crushed and vaporized, it received a radiation dose equal to 25 million dental X-rays. Let that sink in. 25 million. This is not a peaceful planet. This is a death trap.
And Jupiter doesn't leave its neighbors alone. Its gravity is a cosmic wrecking ball. Early in the solar system's history, scientists believe Jupiter migrated inward, wandering as close as Mars' current orbit, before getting pulled back outward by Saturn. During that rampage, it smashed or threw away most of the rocky material in the inner solar system. That's why we have an asteroid belt. It's not the remains of a destroyed planet, that's a myth. It's debris from planets that never got the chance to form, because Jupiter wouldn't let them. There's a theory called the Grand Tack Hypothesis. It suggests that Jupiter's early migration destroyed or ejected most of the building blocks that could have made other planets. Mars should have been much bigger. Earth might have been different, but Jupiter said no. And Jupiter's gravitational bullying isn't just ancient history, it's still happening right now. Comets, asteroids, rogue chunks of ice drifting through the solar system, Jupiter acts like a gravitational vacuum cleaner. It either swallows them, deflects them into the sun, or flings them out of the solar system forever. In 1994, we watched this happen in real time. Comet Shoemaker Levy 9 got too close to Jupiter. The planet's gravity tore it into 21 separate fragments. Then, one by one, those fragments slammed into Jupiter's atmosphere at 60 kilometers per second. The impacts left dark scars larger than Earth. The energy released was equal to millions of nuclear bombs. If that comet had hit Earth instead, extinction, no question. Some scientists argue that Jupiter protects us from such impacts. Others point out that Jupiter's gravity also sends objects toward the inner solar system, increasing our risk. The truth is probably somewhere in between. Jupiter gives, and Jupiter takes away.
What about its moons? You might think at least Jupiter's moons are safe. Europa has a subsurface ocean, one of the best places to look for alien life. Ganymede is the largest moon in the solar system, bigger than the planet Mercury. These seem like peaceful worlds. But even Jupiter's moons exist in a radiation hellscape. Io, the closest large moon, is the most volcanically active body we know of. Not because it has internal heat like Earth, because Jupiter's gravity literally kneads it like dough. The tidal forces are so extreme that Io's surface is constantly erupting. It reshapes itself every few years. You could land there, but you'd be standing on a volcano that might explode at any moment. Europa, the moon with the promising ocean, orbits right inside Jupiter's radiation belts. The radiation on Europa's surface is lethal. Any spacecraft that lands there will have to drill through kilometers of ice just to have a chance at finding shielded water below. And even then, the electronics face constant bombardment. Ganymede has its own magnetic field, the only moon in the solar system that does. But even that isn't enough to fully protect it from Jupiter's radiation onslaught. It's like holding an umbrella in a hurricane. These moons aren't refuges. They're prisoners, trapped in orbit around a bully that never stops.
Let's pause here. Jupiter isn't dangerous in just one way. It's dangerous in every way at the same time. Pressure crushes, radiation kills, gravity traps, storms destroy. Magnetic fields accelerate particles to relativistic speeds. That means nearly the speed of light. There is no safe approach to Jupiter, no safe orbit. Every mission we send there is operating on borrowed time. And here's the part people often overlook. Jupiter is still actively shaping the solar system. Its gravity influences the orbits of asteroids. It bends the trajectories of comets. It even causes a subtle wobble in the sun itself. In a very real sense, Jupiter is still deciding what survives and what doesn't. So why do we keep sending spacecraft there? Because the terrifying things about Jupiter are also the most scientifically valuable. That liquid metallic hydrogen interior, it could teach us how gas giant planets form throughout the universe. Jupiter's radiation environment is a natural laboratory for understanding magnetic fields and charged particle physics. The moons, even in Jupiter's deadly shadow, might be habitats for life.
If anything can survive there, it changes everything we know about biology. Juno has been orbiting Jupiter since 2016. The data it returned has revolutionized our understanding. We discovered that Jupiter's core isn't solid like we thought. It's a fuzzy, diffuse region, possibly still absorbing material from impacts billions of years ago. We learned that Jupiter's atmospheric dynamics extend far deeper than expected. The storms aren't just surface phenomena. They penetrate hundreds of kilometers into the planet. And we've confirmed that Jupiter's auroras, the glowing lights at its poles, are powered by interactions with its moons. Io's volcanoes spew material into space. That material gets ionized and funneled along magnetic field lines. The result is light shows that dwarf anything on Earth.
But even with all this knowledge, Jupiter remains fundamentally alien. We will never walk on Jupiter. There's no surface to walk on. We will never establish a base in its atmosphere. The pressures and radiation make it impossible. Even robotic exploration is limited. Our best spacecraft can only survive for a few years in Jupiter's vicinity, and even then, only by carefully managing their orbits to minimize radiation exposure. Jupiter represents a hard boundary, a place we can study but never truly inhabit, a constant reminder that the universe wasn't designed for human survival. Here's the cold truth. Jupiter has been here for 4.5 billion years. It was here before life existed on Earth. It will be here long after humanity is gone. And during all that time, it has never stopped being violent, never stopped being deadly, never stopped being hungry. When you look up at the night sky and see Jupiter as a bright, steady point of light, you're not looking at a peaceful neighbor. You're looking at a storm that's been raging since before the dinosaurs, a radiation source that would kill you in minutes, a gravitational well that has shaped the fate of worlds. Jupiter isn't the king of the planets because it's noble. It's the king because nothing else survived long enough to challenge it. I hope this changed how you see that little light in the sky. Our solar system is far more violent than it looks. Jupiter is the proof. If you enjoyed this, consider subscribing, and I'll see you next time.